Hello, everyone. Hope you're having a good conference. So this session is about our journey and experience of using Postgres. I must admit, it's a quite a strange feeling that I'm sitting here by myself and recording this video. Conferences are usually about sharing ideas, sharing experiences, meet new people, and I'm sitting here by myself making this recording this video. So I understand it's a quite a difficult time, and then we should basically adapt towards the new ways of working and new ideas. So it's also a unique experience. So what I like to see is we still having this conference or this session is a bit more interactive. So what I like to also ask is that you send your write your comments, share your thoughts, share your ideas. And then maybe we are able to take some of those questions at end of this recording, end of the session. So this is IKEA Retail in nutshell. So we are quite a big retailers. We are present in 30 different countries, having 374 stores, big blue boxes, as we say. And then there are quite many customer meeting points. So that's the total turnover of 36.7 billion of euros. There are lots more customers that were visiting IKEA online, but then they're also visiting on IKEA store app. We have, over the years, we have seen a quite number of increase in the sales, which are basically through online. And then we have about 166,000 co-workers all across Inca countries or IKEA retail countries. So there is quite a lot of interesting fact behind it. So what we're basically saying is there is quite a lot of business operations that we run in 30 countries. So there is a supply chain systems behind it. There are financial systems behind it. There are customer solutions and then the coworker solutions to run such a large operations. And most of these information are stored in the databases that what we have for IKEA. There is quite a lot of information is stored in the databases. There are quite a lot of information which is integrated, sent out to different systems, received to a different system, sent out to external partners that what we have in supply chain and the other areas. And these databases services, that's something we provide to IKEA Retail. So my name is Dinesh Adhikari. I'm an infrastructure manager for databases at IKEA Retail. Together with my colleagues and some of the collaboration partners, we create these database solutions for IKEA for services to use. That we have an internal users, which are applications which are using these services, and all the e-commerce that where we see a large number of growth. Those informations are stored in our databases. Those services, platform standards that we create for IKEA to use. We are using databases for quite a long time. We have built different database versions over the years. We have done quite a lot of LCMs. We have built our ways of working around this, and running a database operations is a bit an old task. That's something we are doing within the company. But over the years, since such a large number of stores are grown, business operations are grown, we have seen there is quite a lot of challenges that occurred over the years. We have created quite a lot of complexity when it's coming to how we work with the databases or what our databases can provide. We've been, as I said, we've been using databases for quite over the years. We have worked with mostly proprietary databases in our portfolio, so that every time when there is a need for coming to a database, we just go okay, now it's you are going to use this database and this database only. And that has worked for us so far. That has worked quite nicely, but we see that there are gaps, there are shortcomings are keep coming into. And there has been quite a lot feedback we have received, quite a lot of feelings that what we have received that, okay, that our operations which have worked so far probably will face or already facing quite a lot of challenges. We are not quick enough. We are not doing enough to meet what is required from us, how we are changing our landscape, application landscape around us. So what we said is, okay, it's been happening a lot. So a couple of years ago, we started basically an assessment. What we want to do is whatever approach we will build has to be backed up by the data. So what we have done in that approach is we made quite a big assessment. It was a huge review that what we have done for our landscape. We went to every corner, we basically uplift every stone, and then we want to know what we have, how we are running, how before we make any directional saying this is what we want to do. So in this review, we have looked at our deployed base. So how many databases do we have? Where these databases are running? Do we run in our data centers? We have stores, that's where we have some solutions which use the databases. What kind of databases that what we have in place? What are our policies? How we are creating those processes? What kind of process do we have existing today when it comes to deploying those databases, removing those databases, making modification on these databases, and how they are fulfilling the need of what we have and where they are in terms of meeting the need in the future. We also looked at inside the DB operations, what are actually our DB operational teams are doing, what kind of workload they are handling, what kind of challenges do they face, what kind of task categorizations they have. So it's this whole assessment is to dig down each part of this for the operations and then the whole state. That one of the interesting fact that what we said is that usage, what actually we have inside those databases. It's perfectly okay that you require a database, so we create a new database, but what does we actually run inside the database? What kind of logics are coming in? What kind of codes do we have in place? So we are looking that usage part is purely from a database point of view. And then we did also a little bit of mapping on that our applications, so that what kind of applications we have. But the main usage part was more digged inside from a DBA point of view, from a database operations point of view, from a database capability point of view. But at the same time, we also look at, okay, what kind of capabilities do we need? So we had some discussions with architects. We also spoke about some of the application owners. So here, in this case, we were just looking into, okay, what we are missing? What do we need more? How can we make better services for applications to use? And the last part is in that review was basically a TCO. So it's not about a database licensing cost, or it's one particular cost in compute or somewhere else. So here is the total cost in terms of, okay, how does it cost to run a DB? How it's cost to build on a DB? How much is it cost to LCM? So that there are the costs we actually look from a different aspects to get an understanding of our whole state. It was quite an interesting activity. It ran for a little over 2 months, I think. That is involved with a lot of people, a lot of discussions, a lot of data gathering, all the fun analyst work to get the pictures that what we want. And then the findings, the outcome was very interesting. So there are quite a lot of facts that came out to us, which we probably would have ignored if we just keep looking the database from a holistic point of view. But we went in and then find out quite a lot of details in here. So some of the facts, for example, we found out that we have a more development test databases than the actual production itself. So I can't remember exactly how many numbers were in ratio, but then it was quite a high number compared to the production databases. So that tells us something about we do quite a lot of testing, so that's a good thing. But then we spin up a lot of instances, probably then more than what we need. We also learned that our provisioning is quite slow. It's quite a backed up by a heavy process. That's where we have a lot of handovers between the different teams to get in this place, so that the provisioning process was extremely slow. And unprovisioning or decommission was even slower. So of course, I understand that the decommission is quite slower because the people want to be very much sure on what we are actually removing. But it takes quite a lot of effort to get a database in place. And then it takes quite a lot of efforts to get the database off the place. And just because of this complexity of getting provisions and unprovisioned, so then the rate of unprovisioning was quite low. So means we are provisioning more, but then we are not removing enough. And that is adding to complexity to our operations. That is adding the total TCO to run those databases in place. And at period of time, those databases that what we have in a large test environments, they start to live their own life cycle. So the state is becoming, sometimes it's becoming so contaminated that even though it's a test and development databases, but they cannot be used because they need to be refreshed, they need to be deleted, they need to be recreated again. So that was quite an interesting finding from a fact point of view. DB operations are a bit mundane. So the DBAs are basically engaged in creating storage. They are involved in creating data or creating table spaces, extending table spaces. They are involved in creating data refresh cycles, backups, monitoring backups job. So it's become quite an mundane operation to run. And what we also learned that our compute utilization is quite low. So it's whatever compute capacity what we are provisioning, we are not using so much. So we create databases, we create in a compute infrastructure, we allocate storage, we allocate servers and CPUs and memories to secure quite a lot of things, but then we are not utilizing so much in the end. And once we looked inside the databases, we found many of those databases, they have a flat data structure. So some applications are using the just databases to store data in table and columns. There are no relations, or there are minimum relations, or there are very little code inside. So that was actually quite an interesting finding. We would have not. Usually we don't go inside in databases and look what we are running inside, but this was a very interesting fact. And then we also find out that the large number of the databases are like 30 GB, which we call quite a small size. We have a big databases running multiple terabytes, but large number of the databases are quite small. So based on all the data is received, there was quite a lot of discussions in terms of the architects. There was in terms of what is happening in the market. How should we basically position ourselves to make the database as a better an offer for our users than currently what we have. What has worked for us has worked really good over the past, but now the time is coming that the changes are happening in quite rapid fast. You seen the above, we have a 46% increase in sales through the online channels. That means where the e-commerce is kicking up. That means we need to do faster deployment changes. We need to have a better testing capabilities in place. For this is having those long lead times or having contaminated test databases probably not not a very big help. So that's where we need to do a turnaround around this. So we decided to go for database services. So we create database services instead of creating standard database-based deployments. That means there are certain outcomes that what we are looking with that approach. We want to consolidate our databases. We want to improvise our compute utilization. That is a big factor in terms of TCO reduction. We want to leverage that what we are provisioning in a much more nicer way. And then we have adequate of everything, not too much, not too little. And here we want to also create basically an agile and a database platform services where we are basically able to do provisioning on the fly. So where people are able to create databases on demand, they should be able to remove those databases or clone databases on demand. So that means there are quite a lot of agile operations that we want to run on our databases. We want to be able to scale up whenever we have need, or we are able to scale down if the need is not there anymore. So creating those models, which are basically create a flexibility and agility in our database platforms. So we also want to create a fit for purpose databases. As I said before, we have worked with proprietary databases. We have worked with relational databases over the years, but given that the facts that what we have in the assessment, some of those enterprise grade databases are just used to store table and columns. So what does it say? It says, yes, maybe we are not using our database technologies in a right way. So we need to have a better database offering where it basically fulfill the different need. And then there is a balance between the need, there is balance between cost, and also that the performance we require, the availability, scalability that what we require. So we have to define a little bit purposes, and then we also have to find the database products that which are fitting the purpose. And we also wanted to create a DB platform with efficient operations, means that creating tasks, creating automations, creating an environment where things can happen through the machine learnings, through creating a capabilities which trigger certain response and fix those mundane jobs in a much more better way. We also looking is the new capabilities we have. How should we handle encryptions in a better way? How should we handle data replications in a better way? How should we work with our test data? How should we back up? How should we recover? So how we are able to work with these new capabilities in this target outcome. And of course, is the TCO reduction. So how we are, since if we are able to put a lot of automations in place, then how does it impact our TCO? We want to reduce the TCO, of course. As I said before, if we are not using our compute quite a much, we are deploying proprietary enterprise grade databases for a very simplistic of the jobs, then probably we are not using our investments in a good way. So we want to have a reduction of the TCO. So that was our target outcome of the strategy, that what we are hoping for. And having the finding of that we are using, there are small databases, there are databases which are running a simplest code, there are databases which are running simple form of data inside the database. And we wanted to create a better fit for purpose database products. So that where we basically started our journey with Postgres. So in one summer, we basically had a sit down. There were different architects. There were some of the people from our technical team, and in that sit down, we basically decide, okay, how should we approach? It's a quite a new challenge, and it's a quite a lot of journey because now we are expanding ourselves into a total new different domain. So where should we start? What is fit for purpose? So most of our databases are relational databases. So we basically said, okay, it makes more sense to start with a relational database. So in the discussion, we did basically spoke about certain database names. Why should we choose? Why should we go? And in the end, we basically said, yes, okay, let's have a test and learn activity around Postgres. What does Postgres can do for us? What is Postgres? Let's dig down and dip. So we spent a few weeks learning about Postgres. We basically installed Postgres. We created some use cases. We tested Postgres around those use cases, and then had quite a bit activity around this, so that the technical team who worked with the Postgres, they see it is really good product. That's something we can use, and we can use here and now. So some of the reason that why we chose Postgres is it's basically an open source relational database that is quite nice. And then how it worked out from the experience point of view, the simplicity of the product, and then there's quite a lot of confidence in our application team or for our technical team to start using the Postgres. And this one of the feedback which actually I haven't experienced myself, but this is what I got from my colleagues is the community, is the people. That's one of the reason, because the feedback, as I said, is received is the strong community is quite strong. There is quite a lot of contribution. There is quite a lot of development. There is a lot of knowledge sharing happening around the community. So community was another reason for us for going towards the Postgres. And it also has an architecture which is basically meeting our scalabilities, how we are able to create clusters, how we are able to create and highly available environments, highly scalable environments, how we do mission critical applications we are able to bring into a Postgres. So that architecture itself, all the extensions, frameworks that is coming with Postgres is definitely is a quite a big plus. That something we can do. Now, another interesting fact that came in, because what we want to use is a Postgres to run our enterprise applications. So giving up a trial, you test out a database and how do you run it? It is a one thing, but how you are able to convert a database product into an enterprise level of scaling, that's something we had to do some work behind it. And that's where that EDB comes into a picture. Because in able to create an enterprise level of database, we basically needed few capabilities in place. How we are able to create this infrastructure, how we are able to monitor it, how we are able to run operations behind it, and how we are able to secure data that whatever we bring on this platform. So when we started this journey, we had some experience, we did test and learn, but we did not have all the capabilities to create Postgres as one of the enterprise service. That's something we can use within IKEA Retail. So then we reach out to Enterprise DB, and that's where we got quite a good support in terms of creating Postgres as a service in enterprise level of scale. We had quite a lot of sit downs with them, is how we are able to use Enterprise DB, how we are able to use the different tools that coming from Enterprise DB to help us to create a Postgres database service. So what we can see is now we are using one of the Postgres community editions, and then we also have an enterprise Postgres advanced server, I think it's called, for running those databases where we have a bit more PL SQL codes, or they require a better performance in that case. So all this sit down gave us quite a good confidence that the Postgres is quite a good product, and we are able to use EDB help to establish a service within IKEA. And then there are quite a lot of database management tools are coming into a picture. Means those there is a migration toolkit, there is a migration portal, how we are able to do our replications of the data using EDB tools. So that was quite a good help for us to start the service. We used EDB professional services. We had one consultant coming in the beginning, was helping it out. So we create our minimum viable setup, but at the same time, while we're doing this, we basically had a technical team working with the EDB professional service, and then we took quite a lot of learning from that point, which was quite a good invested 2 weeks time, where we learned quite a lot about Postgres and EDB tools, and then the whole knowledge around it. So when we started the Postgres minimum viable, so we were having no immediate users that who can use it. But when we reach out to our technical community, I was actually quite surprised that the people had quite a good knowledge about Postgres. So when we reach out to the people, that was seen as quite a positive feedback, and we took this feedback as quite a positive sign to start something with the Postgres. This is something we can do. It can be immediately used. And then we got a support from EDB. So even though we are running it in a community editions or enterprise, that's where we have a EDB. So that's where we have a possibility to create tickets and acquire support whenever we have a need for it. So some of these topics are quite high level, which basically give us quite a lot of confidence to use Postgres as a service for IKEA, an open source relational database, which is something I would say right on target. But our data modernization does not really end here. It is basically it is in a journey. That's something we continue. So we have included one database in our portfolio, but there are a lot of directions that what we are looking at. There are highly automations we are looking at. We want to create and scale and agile. So currently we are working with quite a lot of initiatives to reach our target. So Postgres is definitely a plus. It is in quite an addition, but our journey does not stop here. So now we are basically engaged in quite a lot of initiatives and see that how we are able to create a better service to use for IKEA. I think it's going to take quite some time before we get there, but we are definitely on the right track. And having Postgres and all the support with EDB give us the capability and a good experience and confidence to move in this direction. So this slide, I usually have it for questions, but then I guess we will take the questions when we arrive at the end. And so I hope you had some questions and you some feedback sent out already by now, so we can take them as they come. So thank you all. So thank you from behalf of me and my colleagues to listening to the sessions. Now we are looking forward to your questions and your comments. Thank you.
Enjoy the rest of your day. Thank you very much, Dinesh.
Thanks, Lauren.
Thank you. Oh, we've